For those of you who are currently undertaking GCSEs, I hope they're going well. After seeing last year's prediction video, several of our students have asked for one for this year. So let's go back in time to a galaxy far, far away and see what came up in paper 1.
Maths prediction, papers 2, 3 and 4.
Wait, there's no paper 4. Okay, so back to the future. I have a couple of caveats before we get into the predictions. Number 1, this is not a complete list, but we have tried to include the majority of topics that are likely to appear in papers 2 and 3. Number 2, it's important to note that if a topic has already appeared in a previous paper, it doesn't exclude it from coming up in future papers. So if you've seen a topic in paper 1, it doesn't necessarily mean that it cannot come up in paper 2. And the final point, remember that this is just a prediction. Okay, so let's go. Here are the topics we believe may appear in papers 2 and 3. The first thing on my list, algebraic fractions. Make sure that you can simplify these, but also carry out the 4 main operations of addition, subtraction, multiplication, and division with algebraic fractions. Number 2, circle theorems. Make sure that you're able to use and apply these, but also prove them. Number 3, trigonometry, both right angle trigonometry, but also make sure that you know the sine and cosine rule, and again, be able to apply them. In addition to that, knowing the formula for the area of a triangle and when to use that. Fourth thing on our list, ratio problems. Number 5, the product rule for counting. Make sure that you know that. And number 6, working out the HCF and LCM of 2 or 3 given numbers, but also you may find a HCF and LCM question that's given in context, i.e. some sort of worded problem. To watch me go through one of these types of questions, click up here. Number 7, quadratics. Now, quadratics is quite a big topic, so there's several things that you need to know. 1, make sure that you're able to deal with quadratic inequalities. 2, make sure that you're able to sketch quadratics and graph them and know the various different points on a quadratic graph, i.e. the roots, the solutions, turning points. Make sure that you're able to solve quadratic equations by either completing the square, using the quadratic formula, or factorizing. Number 8 on our list is vectors. Make sure that you're able to deal with vector proof questions. Number 9 on our list is percentages. Now, there's several different percentages question types that you could get, so you may be asked to just simply calculate the percentage of an amount. We've seen reverse percentages come up in paper 1, but again, it may come up in paper 2, dealing with multiple percentage changes. So maybe using percentage multipliers and compound interest questions, but also calculating a percentage change between 2 numbers. So, when something has started up as one value, it's changed to something else, and then working out the percentage change from those 2 values. Number 10 on our list is 3D trigonometry and Pythagoras. So with those sort of questions, usually what you want to do is break up the 3D shape into a series of triangles to help you find out the missing angle or the missing side. Next on our list is changing the subject of a formula. Make sure that you know how to do that. In particular, make sure that you know how to do that when the subject appears more than once. After that, we have compound measures. So make sure that you know your formula triangles for density, mass and volume, pressure, force and area, speed, distance and time. Next up, standard form. Make sure that you're able to change numbers from ordinary into standard and vice versa. But also make sure that you're able to carry out the 4 operations with numbers that are in standard form. Right, so that's addition, subtraction, multiplication, and division. After standard form, we have algebraic indices, so make sure that you know your index laws and are able to apply them. So next on our list is cumulative frequency graphs. Make sure that you're able to use and interpret them, and also use them to estimate medians and quartiles. Next up, we have graphing a region from inequalities. Remember with these that you need to look at the inequality and choose the correct side of each line. Also remember, use dotted lines with less than and greater than, but use solid lines for less than or equal to or greater than or equal to. Next up on our list, we have direct and inverse proportion. Remember, you can also get inverse proportion questions in context. Those are those rate of output questions. Click up here to watch us go through an example of a question like that. Following that, we have functions. Make sure that you're able to come up with composite functions, but also to come up with inverse functions. So following that, we have surface area and volume of 3D shapes. So those are your prisms, cylinders, cones, and spheres. Next up, we have iteration. So solving certain equations by using an iterative formula. Normally with those problems, you're given some sort of starting value to use for the iterative process, or you can work out the starting value by looking at the graph and finding where the graph crosses the x-axis. Following that, we have algebraic proof. So when you're given a statement and then you're asked to prove it algebraically. After that, we have estimating gradients. Now that's usually going to be from something like a velocity time graph or a distance time graph. So remember, if you're estimating the gradient from a velocity time graph, that represents acceleration. And also make sure that you're comfortable with working out the area underneath a curve and make sure that you know what that represents. So usually if it's from a speed time graph, between 2 times, the area underneath will represent the distance covered. We're yet to see frequency polygons appear in paper 1. So potentially that could come up in paper 2 or 3. Also, loci, construction and bearings. Make sure that you're able to do things like drawing the locus of a set of points that follow some sort of property, constructing perpendicular bisectors, and for bearings, make sure that they're always measured clockwise from north and given as a 3-digit figure. And finally, transformations of functions. So knowing how to draw a transformation of a function and also work out new coordinates when given a transformation. So the transformations in particular that you need to know how to deal with are the translations and reflections. So those are questions where you get given the graph of y equals f of x and maybe have to sketch the graph of y equals f of x plus a or y equals f of minus x, or working out the coordinate following a transformation. So those were my predictions. I'd suggest taking a look at the list in the description and prioritizing the topics that you feel need strengthening. So for example, if you've forgotten how to construct a perpendicular bisector or how to draw a locus of points that satisfy some property, but you're a pro at dealing with algebraic fractions, then it would make more sense to dedicate more time to loci and constructions. I hope you found the video useful. To watch another video, click here, here, or here, and don't forget to subscribe.